Hello and welcome to the special lecture of Calculus 1, where we are going to talk about tangent lines. These problems you are going to find in every section of chapter 3. So this is not 3.9, this is just a standalone short lecture to introduce and talk about tangent lines. So we learned in 3.1 that if you have some kind of a function, you can find a tangent line at the point A by figuring out the derivative and computing the slope, right? So if you find the derivative and compute at point A, you will find the slope of the tangent line. To illustrate this, we used limit procedure, which since we retired, right? We used the limit procedure to do the tangent line earlier, and then now we have the shortcuts for derivatives, so we don't have to bother with the limit. But in 3.1, we said that the slope of the tangent line was the limit h goes to 0, or f of a plus h minus f of a divided by h. And let's say you had function x, f of x to be x squared minus 3, and you want to find the tangent line at x equals, let's say, 2. Well, in 3.1, which could be featured obviously on your exam, you create f of a plus h, in our case is f of 2 plus h, which would be 2 plus h squared minus 3, which is 4 plus 2h plus h squared minus 3, and f of 2 plus h is going to be 1 plus 2h plus h squared. Then we also needed f of a, which in our case is f of 2, which is simply 2 squared minus 3, which is 1. And now we feed all of that stuff into the limit to find the slope. Now this is the painful way. And since we discovered the shortcut, so we don't bother with this limit. So we have our 1 plus 2h plus h squared minus 1 over h. Ones cancel, and when you copy the limit, obviously h goes to 0. You factor out h, you get 2 plus h divided by h. This is where h dies. And when you send the other h to 0, you get 2.
I have one question. When you do the folding, it's supposed to be 4 plus 4h plus h.
Oh, yes, you're right. Good. This is a 4. That's a 4. That's a 4. That's a 4. And this is the answer is a 4. You are completely right. Yep. Good. So slope of the tangent line is 4. We have the function f of x is x squared minus 3. And we have that x is equal to 2. I can calculate the y value now as 2 squared minus 3, which is 1. And that gives me the point 2, 1. Y equal mx plus b. Plug in y, which is 1. Plug in m, which is 4. Plug in x, which is 2, plus b. And that is going to be 1 equals to 8 plus b. B equals to negative 7. It's just basic algebra to find equation of the line if you have a point and a slope. Just plug in. And we have our tangent line at y equals 4x minus 7. Now, if you want to check this, all you need to do is to graph your function, in our case x squared minus 3, and then graph your line, tangent line, which is 4x minus 7, and they better have a tangent at 2, and you can see that at 2, right, they touch. -7. And we know it's good because, as you can see, they do touch over here at x equals 2, 2, 1. The tangent line touches the function. So 100% okay. So now what happens next? Well, now we're moving through the chapter and making this calculation much faster. Let's say 3.3. Again, tangent line. So 3.3, tangent line, function given by 1 over x, and the x equals to, let's say, 6. Those are the specs. Here is the formula written in blood. Slope of the tangent line is the derivative computed at a. This is your formula for the tangent line. You will find the derivative f of x, which we said it's -1 over x squared. And then you will calculate the derivative at 6, which gives you -1 over 36. And that is the slope. So this is now the joke of calculation. We don't have to go through the limit and all of that stuff we did before, because now we know the shortcuts for derivatives, and you would find the derivative quickly, and then you will plug in the value for x, which is given to you, and you will compute the slope literally in 2 or 3 lines. That's it. Now you will compute the y value. Y is 1 over 6, and now you have m, and you have the 0.6, 1 over 6. So y equal mx plus b. Your y is 1 over 6. Your m is -1 over 36. Your x is 6 plus unknown b, which is the y-intercept you are looking for. These guys will cancel, and you will have 1 over 6 equal to -1 over 6 plus b. When you add them, you will get that b is equal to 1/3. Because you will get 2 over 6, right? That's 1/3. So the tangent line is y equals, the slope is -1 over 36 times x plus 1/3. And problem is solved. Every single problem, doesn't matter the section, guys. Every single problem, regardless of the section, is done the same way. Take the derivative. You have to know whether derivative is basic, product rule, quotient rule, chain rule, implicit. That's your knowledge. The procedure for the tangent line is always the same. Step 1, get the derivative. Step 2, compute the slope. When you plug value in the derivative, compute y, compute b. 1, 2, 3, 4, done. So let's have a problem that has, let's say, product rule. Say your function f of x is given as xe to the 2x, and you want to compute the slope at x equals 3. So looking for the tangent line. Okay, now I have the product rule. So we have to copy the first, take derivative of the second, plus copy the second, and then take derivative of the first. You simplify by kicking e to the 2x outside, getting 2x plus 1 in parentheses. Your slope m is, when you compute 3 inside the derivative, so e to the 6 times 7e to the 6. How about that? Boom. Because you will plug in this value to be 3 and this value to be 3. So e to the 6, and then you have 6 plus 1 is 7. So 7e to the 6 is the slope. So that was the first part, computing the slope. Next one is to compute y. And y is equal to plug in 3, so that's 3e to the 6. When you plug in 3 into original function. And now I have everything. Slope is 7e to the 6. And the point is 3, 3e to the 6. Plug everything into y equal mx plus b. Y is 3e to the 6 equals to slope is 7e to the 6 times x, which is 3, plus b. 3e to the 6 equals 21e to the 6 plus b. And we see that b is equal to negative 18e to the 6. Tangent line is y equals 7e to the 6 x minus 18e to the 6. E to the 6 is a number, so don't freak out, right? You can punch that in your calculator and get decimals. It's a number. So you can even kick that outside. Here, e to the 6, and then you have 7x minus 18. All right, that's easier to swallow. This particular problem used product rule. Well, that's from 3.4, right? 3.4 used the product rule. We really don't care what kind of derivative we have for the tangent line. Every procedure for the tangent line is take the derivative with whatever you have to, and then plug everything in. Let's take a look at the chain rule from 3.7. Say y is equal to, let's do your favorite, secant of, I know you love this stuff, so, right? How about a secant of square root of x over 2? Why not? The point is, let's say, x equals pi squared over I don't know if it's gonna work. No, I don't know. Hold on. I have to meditate on this. I really don't want to think. I'm just gonna give me 1 second so I can. I'll be right with you. Don't panic yet. I'll tell you when to panic. All right, so x is better work because I am tired. 4 pi squared over 9. Beautiful. All right, same procedure. We find the derivative first, and then we plug the numbers. So, what's the derivative? Derivative of secant is secant tangent. So we have x over 2, tangent of square root of x over 2, and then I have to take the derivative of the inner function, which is 1 over 2 square root of x over 2 times 1/2. Very good. A little bit convoluted. So this whole derivative mess simplifies into 1 over 4 square root of x over 2 secant square root of x over 2 tangent square root of x over 2, and let's call it good. All right. So now, to calculate the slope m, I will plug in the value of 4 pi squared over 9. So now that's going to populate everywhere. So that's 1 over 4 times the square root of 4 pi squared over 9 divided by 2 times the secant of square root of 4 pi squared over 9 divided by 2 times the tangent of square root of 4 pi squared over 9 divided by 2. Yeah, I'm not happy. I don't think it's gonna work. Maybe it will. I don't know. Let's stick with it, and then we can just abandon the problem. So 2 and 4 will see. Then I can't take the derivative. So this 4 needs to be. This 4 needs to be an 8. Okay, we can fix that. 4 needs to be an 8. So 4 is going to be an 8 now. I'm just going to plug in 8 everywhere. Easy. There we go. All right, what do I have? I have 1 over 4. 2 and 8 will cancel to the square root of 4 pi squared over 9. That's easy now. Times secant. What is the 4 pi squared over 9 cancel into? 2 pi over 3, right? So I have 2 pi over 3, tangent 2 pi over 3, and those are some easy angles to deal with. So the slope is 1 over 4 times 2 pi over 3. Secant is 1 over cosine, so that's 1 over cosine of 2 pi over 3, and we have tangent of 2 pi over 3. All students take calculus. And now we go m equals 3 over 8 pi. Cosine of 2 pi over 3 is here, so it's -1/2. So 1 divided by -1/2, and then tangent of pi over 2 pi over 3. So tangent of pi over 3 is root 3, so -√3. This is perfect. Negative will kill negative. 8 and 2 will cancel. So I have 3 knockoffing root 3 divided by 4 pi. There we go. We got it.
I'm sweating.
That's the slope. This is a good Thanksgiving problem. Kills a lot of time. So y is equal to the secant of the square root of 4 pi squared over 8 divided by, no, 8 pi over 3 over 9. What the hell was it? 9 over 2, which gives us the secant of 2 pi over 3, and we already know that secant of pi over 3 is equal to negative 2. So slope m is 3 root 3 over 4 pi, and the point is 8 pi squared over 9, comma, negative 2. Y equal mx, lock the doors, plus 2, plus b.
Can you put that in decimals after? I want to see what kind of line that is.
No. Negative 2 is equal to 3 root 3 over 4 pi times 8 pi squared over 9 plus b. Good. 3 cancels 9. 4 cancels 8. Square cancels one of the pi's. And we are left with negative 2 is equal to, I have 2 root 3 over 3. 2 root 3 pi over 3 plus b. So b equals negative 2 minus 2 root 3 pi over 3. If anyone ever bothers you with anything, just whip this out. Like, have it on a flashcard or anything, always in your back pocket or somewhere in purse or whatever. And they say, oh, did I tell you about, look. And that's it. Tangent line y equals 3 root 3 over 4 pi x minus 2 root 3 pi over 3. Done. Easy peasy.
Easy. Oh, yeah. Right off the top of the head.
It's obvious. I mean, nothing you can do with, gallon of coffee and 2 days to untangle. It's not a big deal. One more problem, and what do you mean? Oh, he wants to go home.
Hold on a second. I want to write it down.
Guys, is this hard? No. Is it annoying? Yes. Now you know the difference. Okay? This is what the annoying stuff looks like. Wait for the Calc 2 for hard. That's, I teach it next semester, so
What is like?
I might see some of you.
What's even based on?
Yeah, with the work schedule and, there is the hate factor too. You never want to see my face again, so you totally don't take Calc 2.
Yeah, I'm going to laugh.
Does it look like?
It really does.
Oh, yeah, but this is that.
I'm getting my lessons with that. Yeah, really not that. You're the alpha leg. We're not alpha leg. Pretty much just a little day.
Just a line.
It's just a line. All that work for a line.
Yes. All that work for a line.
I was like, just going to take a picture. I want to say 14
Guys, you're gonna love Monday, I promise.
Yeah, I hate it. Not looking forward to this. I mean, it's.
To Monday? No, you will.
What's Monday?
Monday we'll learn logarithmic differentiation.
Tuesday.
Tuesday we'll learn logarithmic differentiation, and you're gonna laugh.
It's like it's like so far back.
Yeah, depends on how far it is.
Mine's not right now. So it's probably gonna go.
All right, so this problem was on the exam last year or year before?
Which exam?
Exam 2 for Calculus 1.
Will it be the same question on this midterm coming up?
Nah, we're gonna do it now, so we'll put something worse. I mean, different. You guys are well prepared.
Not sure.
Find tangent line, function, oops, lies, for x cubed plus y cubed equals 2xy at point 1, 1. Hello, implicit differentiation 3.8. Look for the tangent line 3.8. Okay, you know the steps. Find the derivative. When you have the derivative, we have to compute the slope by plugging in 1 and 1. Remember that your derivative for implicit has x's and y's in the answer, which is why both x and y are given to you. Right? Right. So you plug in those, and then you have the slope, and then y equal mx plus b is the same. You have your x is 1, y is 1, whatever you calculate for the slope. Right. I think, yeah, the answer is obvious. But,
Going into this table,
so obviously, yes.
yeah.
This one, yeah. This might be the good time to remind you of the product rule on the right-hand side.
Copy 2x, derivative of y is dy dx. And you copy y, and then
So the dy
dx is in the wrong terms.
So other than putting that in trying to remember how to do
How to shuffle things.
yeah.
Plus 2 is plus. Okay, there. Copy the first two, derivative y, dy dx. Copy the second one, y, derivative dx. And then dx dx. Good.
So you want dx, dy dx, right?
Yes, dy dx becomes your n when you plug in.
And then all the other terms. I think the class I just got this has
So once you find the derivative, plug in x equals 1, y equals 1, figure out the slope m, and then you have y equal mx plus b to figure out b, and you're done.
so this is 2, right? This is 2.
All right, we already have a solution.
Just. Oh,
Two, right?
y equals.
Yeah.
Right. It's like that's all that comes from the cake, but it's in nice.
So the algorithm is
It's necessary evil because chapter 4 will be really nice if you can't do it.
All right, so now I'm going to show you a boss move for implicit differentiation. We are going to take derivative the regular way, right? We have to take the derivative in respect to x to eventually figure out the slope. And when you take the derivative, you get 3x squared plus 3y squared dy dx equals to product rule. Copy the first, derivative of the second, plus copy the second times derivative of the first. All right, here is the boss move. I am not going to solve this for dy dx. I'm just going to plug in everything right there, replacing every dy dx with m. So my x is 1, my y is 1, and my dy dx is m. Plug in. So you do not have to shovel a lot of algebra at all. So when you plug in x equals 1, you get 3, plus y squared, that's a 1, so it's 3m, equals x is 1, so you have 2m, and then you have plus 2. That's called the boss move. From here, m is equal to -1 in the next step. And now y equals mx plus b, y is 1, m is -1, x is 1, plus b, b is 2, and y is -x plus 2, as I have foreseen. Tangent line. Be gone.
Much like